Okay, let's begin today. How are you? How are you? How was your weekends? Tired. Usually responses are fine, thank you, and you. Otherwise, tired, boring, and other stuff. First thing, on the Hanyangin, did I upload the first set of assignment? Anybody check the Hanyangin website yet? So it's a simple written assignment. So I'm gonna ask a few questions from textbook, which is quite similar to the previous questions that I asked in the previous years. So you can take a look at it. The question is probably covering chapter 1 and 2. In order to solve some of the problems that you need to read the textbook anyways. So this is your time to start reading. So questions are quite simple this time. Usually the first assignment, written assignment, I'm planning to give you the second assignment as a programming assignment. So written assignment, programming assignment, and then go back to written assignment, and maybe small bit of other programming exercise. So don't worry too much about programming yet. So I'm just saying it because it might give you some time end of this week. So check your Hanyangin regularly, at least once over the weekends, then you'll be okay. And start your assignment early as possible. I usually give you 2 weeks to finish your writing assignment. You can finish in half an hour, an hour to finish. So it's not going to take that long. Okay. Anybody started yet? Assignment 1? Yeah, I guarantee you, less than an hour, you can finish it off. Writing assignment usually easy. Okay. Anything else? Did I forget anything? Probably not. If I remember, I will let you know. Okay, so last class, we were discussing a bunch of problems that we could solve with this pseudocode approach and algorithms that we were discussing, right? What was the final algorithm that we looked at in the last class? What was it again? Anybody remember? That was on Wednesday, was it? What was the algorithm that we discussed in the last class? Yeah, pattern matching, right? So this is your stuff. I'm just going to do a review. This is what I would usually do. In the first 10 minutes, I would just do a review on what we discussed previous class. And then, because I know that after a week, then no one's remember anything from the class. So I try to remind myself at the same time. I would like to remind you as well. So pattern matching algorithm, they asking to give us an algorithm or more of a pseudocode in this step to come up with a pattern matching algorithm. So they give a long sequence of characters, and then they give you a smaller set of sequence of characters. Example that we used was ABCD, right? ABCD. And then we try to slide that. Here they say forwarding, I think forwarding or something. I call it as sliding window of a pattern matching algorithm, right? One by one. And one of the characteristics of the pseudocode was what? It seems the final pseudocode they presented in your textbook was having one big loop inside. Also, there's a smaller loop inside of one big loop. Why? Why we're having a loop inside a loop? What was the reason of it? 아이고 힘들어. Why there was? This was the another pseudocode. Maybe this was simpler. Yeah, this one. There's a one big loop outside and then there's a smaller loop inside. What was the general idea of having this two loop? 뭐야? 왜 그래? I don't want to write it again, but one big loop to go through the entire sequence. Smaller loop is to compare every time I slide, right? Smaller loop, big loop. So I can advance one by one. At the same time, as soon as I advance, I need to check whether I have that sequence where I am. Index, right? Am I in the different class? 왜 그래? 나 맞지? I'm in the introduction to computer science, 그지? After 2 weeks of university life, you guys already become like your seniors. 딱 2주 만에 여러분들의 선배들과 눈빛이 똑같아져 버렸어요. 미치고 환장하겠네. 그죠? I also teach third year class. 오늘 아침 눈빛을 보니까 약간 썩은 동태의 눈들이 돼가지고 비슷해져 가고 있는 2주 만에 대단한 대학입니다. 2주 만에 이렇게 초롱초롱한 애들을 정반대로 만들어 버리네. Right? So 2 loops and 2 loops. I also, because I'm mentioning this because I want you to get the general idea of how to represent your pseudocode. I mean, even though you let's say that you don't get exactly what they try to do, but you can see the overall structure of this pseudocode. Right? So in the exam situations, midterms, you don't know how to do it for each part maybe, but you can do an outside construction of the general outlines look like. I may give you 50% of the full mark. Right? That's a start. Just don't expect to do everything from the beginning. You can't do it. You need time and practice. So that's your practice steps doing it. 대충 구조를 보는 것부터 시작하라고요. 처음부터 한 줄 한 줄 읽어보고 얘네들 왜 이렇게 하려고 그러면 감이 잘 안 와. 감이 잘 안 와. 물론 오는 사람도 벌써 있겠지만 감이 잘 안 와요. So I'm sure you can certainly come up with the different type of algorithms of pattern matching. Anybody looked it up, pattern matching algorithm that I mentioned last class? I also suggest you to type up a sequence matching algorithms on the Google. If you haven't done it, try to do it. I also mentioned that these type of algorithms are many. You can certainly download it. You can run your own programs. You don't have to write it on your own. That is the beauty of this type of algorithms. Very complex, but already some people have done much work. Just we can simply use it. I also mentioned briefly that's what we should do, right? Instead of writing on your own, maybe it's much more convenient to use someone else's proven algorithm to implement your own programs. To me, that's a good programmer. Of course, the other type of good programmers, they can do it themselves, but less likely. For us, I think, where things are, how to use it, how to borrow someone else's code integrate in your own program, that matters to me. Okay? So looking for Okay, so this was a summary of chapter 2, algorithmic design. First step in developing an algorithm. Some algorithm must be ensure the algorithm is correct. Ensure the algorithm is sufficiently efficient. We didn't discuss too much about efficiency yet, right? But chapter 3, we were discussing in how good your algorithm is. Usually in terms of speed, or some cases in terms of memories that your program takes. And pseudocode, hopefully, after this point on, if I give you the problem, then you can come up with your own pseudocode. Must be readable by me. Okay? It means that you have to write it clearly. Also, you don't make it, you don't write it on your own paragraph. I'm asking you to simple, precise, unambiguous instructions so the others can understand what you're trying to do in order to solve the problem that you're given. So I think you guys are having a experience. So hopefully your assignment will give you a chance to practice. Maybe follow some of the given pseudocode, like debugging ways. X is 1 at line 2, and then X become 2 at line 5. Those type of steps that I show you on the board, right? Maybe that's the first thing that you can start. Hope if you're lucky, you might be find some problems in a given pseudocode, and maybe report me. Maybe you can come up with the error cases. If I give a certain inputs to a pseudocode, given pseudocode, this pseudocode doesn't work. Maybe you can find exception cases, and you can. It's a good start. Algorithmic design, blah blah blah, top down, bottom up. It's all different from case to case. Abstraction, key tools for good design. I will mention of this more as we proceed to the next chapter and so on. So my final question in this chapter, any questions from you? Still not clear on the pseudocode, still not clear on the algorithms. Any final questions on this chapter? 혹시 질문? 이제 알아볼 만하죠? 이제 슬슬 지겹기 시작하죠, 그죠? 알고리즘, pseudocode. Okay, next chapter. Let's take a look. Now we know what algorithm is. Now we know the procedure of try to solve a problem in terms of writing pseudocode and translate that into an algorithm. Translate that into a program. And we know the very basic step now. I briefly mentioned last class too. Now it's time to look at how good is your algorithm? How do you compare your algorithm to someone else's? How do you determine that whose is better than the other? Whose algorithm is better? How do you do that? So we need to find out a few things like attribute of the algorithm, parameters of the algorithm, attributes. In order to compare something, that you need to get the characteristics, right? Characteristic. You can think of attribute as a characteristics, features of your algorithms. Measuring efficiency. What is a measurement? What is a measure? 측정. You measuring efficiency, 효율성. But it's not clear. Measuring efficiency. Measuring efficiency means could be a lot of different meanings, right? Analysis of algorithm. Is your algorithm good or bad? Or sometimes is your algorithm will be working or not? Is it going to work for all possible inputs or not? Some of the algorithms that we discussed, they had a conditions, like in this example, they were given the length of, I think length of this character should be n, m, right? I think that was another attribute of that. And they also give a conditions that n must be like this. Okay, the same set of algorithm. What if I give or your algorithm will work well with these two conditions or not? I don't know. Some of your algorithm may able to do this. Some of your algorithm, if your condition is outside of this given condition, may not work. Right? Things to, so that's, you need to analyze on those algorithms, and that's one of the conditions of it. Or simple conditions to that people usually make mistake whether your loop is, whether you can exit the loop, right? If you cannot exit the loop, what was happening again? Infinite loop, you're staying in that loop forever. So those are the simple conditions to check whether your algorithm is working or not. When things get out of hand, so you're given an algorithm, you found a problem, can you fix it? Can you fix it? Or is that algorithm runs forever, not forever, but it's too long time that you cannot wait for that algorithm to terminate. What do? What's your second option in such cases? So analyzing the algorithm is an important part of the computer science involving math usually. Finding algorithm to solve the problem of interest. Some of the algorithm better than the others. That's a key question on this chapter. In your second year course, they look into more onto this comparison, performance analysis, performance measurement of this algorithm. In the first year courses, as in our textbook, we briefly touch the idea of what to do. 2학년 때가 아니구나. Next term. 다음 학기에 하게 되는 한 과목에서는 요것만 하게 되는데 지금은 개념 잡는 정도로만 하면 할 거예요. That textbook is much bigger than yours. That textbook will be much bigger than yours. So attribute of the algorithms, characteristics of the algorithms. We expect the correctness from our algorithm. Hopefully our algorithm always produce a correct outputs. Right? Correct outputs. If you use your algorithm repeatedly, sometimes you cannot catch any unexpected outputs because you always assume that your algorithm is perfect. Right? How do you prove that your algorithm is always producing a correct output? That's very difficult, actually. That's very difficult. No program is perfect. No program is perfect. Program maintenance. Fix errors uncovered through repeated use. Sometimes unintentionally you found that your program has a problem. Just like my app in this iPad. I'm using a certain app to display this PowerPoint in the screen. Sometimes I push too many times. I touch too many files at the same time. My program just disappears. App just disappears. I have to restart the app, right? I found that error because I keep using it all the time. So sometimes you need to run your program over and over again, and then maybe you're lucky to get an error messages. Sometimes even if you find the error, there's no way for you to fix. Sometimes you just live with it. Doesn't matter. Extend the program to meet the new requirement. Good programs, good algorithms, let me say, good algorithms. I still remember my first year of the course that I was taking when I was you guys. One of the assignment was just do a simple program. That was the first assignment. Second assignment was like this. Count how many changes that you have to make to do something else. Similar algorithm, but it was doing completely opposite stuff. Completely opposite stuff. And I have to report to the professor that how many lines of the code that I changed. And it would do the exact opposite of whatever it was doing before. Someone's program had to change every single line of the program. Some just change one thing, like this. Maybe your first program they wrote was just try to sort the numbers 1, 2, 3, 4, 5. If you change the inequality signs in opposite ways, it will sort the numbers 10, 9, 8, 10, 9, 7, 8, the opposite ways. Sometimes that also tells you how good your design was. It's one of the examples. My program, I had to fix pretty much every single line of my own program. In Korean briefly, 그런 숙제가 있었던 거 아직도 기억이 납니다. 무슨 숙제가 있었는지 다 기억은 못 하는데 첫 번째 숙제는 무슨 알고리즘을 짜라는 거였고 그 알고리즘을 적어라는 거였고 두 번째 숙제가 처음에 짜온 알고리즘에 정반대되는 일을 하는 알고리즘을 짜오는데 처음 짰던 거에서 네가 몇 개 정도 고치면 할 수 있는지. 그래서 많이 고치면 빵점, 한두 줄 고치면 9점. 좋은 거. 이런 식으로 했던 것 같아요. Somewhat similar to extend the program in a good ways. So you have to have a good start. You have to have a good design to begin with. None of you understand what I just said in English, and then I said in Korean responses. 큰일 났네. 진짜, let me ask you at this point. This is still early in the course. So when I say stuff in front of here, how many of you understand 100%? 70%? 70%? That's good. Even sometimes I don't understand myself 100%. I don't know what I just said. 70% is good. 70% is good. Okay. Still, let me remind you, if you're having trouble, let me know. Talk to me. Hopefully in March, sometime in March. Okay. 갑자기 생각났네. Easy of understanding, another attribute. You're given a pseudocode. Can you understand clearly? Later, if I give you similar assignments, same problem, but someone's pseudocode have 2 loops. Someone's pseudocode will have 5 loops doing the same thing. Maybe sometimes loop inside the loop inside the loop, 3 loops. But the others maybe just need 1 loop to do the same thing. So which one is easy to understand? There is no right answer for that. So that's one thing to consider when you actually try to come up with it. That's on the textbook. At this stage, I don't care. I don't care. As long as your pseudocode works, I'll be happy to see. I'll be happy to see. So at this point, don't worry too much about efficiency of your pseudocode. I don't care too much at this point. Okay. Elegance, algorithmic equivalence of the style. It's more of a programming style. Do you know how the companies judge you when you actually try to get a job in those IT companies? Sometimes they ask you to submit a small piece of program that you have wrote for your assignment or something. As soon as they see it, they can judge on your experience. Not good programmer, but experienced programmer, they lined up quite nicely. Tabs, their valuable names are not A, B, C. They actually give meaningful names. 선도 잘 맞춰져 있고, 가로도 잘 돼 있고, 그런 스타일링을 보는 사람도 있어요. 그게 나중에 좀 쌓이면 나중에 자연스럽게 보일 거예요. 그러니까 여러분들이 4학년이 돼서 1학년 때 했던 숙제를 보면 이게 도대체 막 이런 생각이 들어요. 칸도 안 맞고 별거 아닌 것 같죠? 근데 그게 몸에 배이면 나중에 읽기가 편해요. 알고리즘 마찬가지고. 아까 예를 들어 the previous slide had a pseudocode of finding pattern matching. Imagine that everything is no space in front of it. Everything is start from a no indent, right? Still works, but it's going to quite difficult to interpret what they try to do. So those tiny details also tells you how experienced you are. So be careful when you're actually doing your assignment. Okay. It's not a joke that I ask you to write it clearly. It's also practice of doing stuff. So attribute of algorithm, I know it's not clear yet. The efficiency is another very important attribute of the algorithm characteristics. Terms used to describe algorithms, careful use of resources. Resources here could be 2 things. CPU and memory. Maybe 2 programs doing the same thing, but program A takes 10 seconds of CPU time. Program B doing exactly the same thing, it requires 20 seconds of CPU time. I don't usually care, but it might be nice to have a program with this taking less CPU time. So I can give that CPU time to someone else, like some other programs. Same thing for the memory. Some programs take maybe 10 megabytes. The other takes 20 megabytes, even though they are doing the same thing. So that might be one easy interpretation of that sentence. Benchmark, used for rating one machine against another. And for rating how sensitive a particular algorithm is with respect to variations in the input on particular machines. 이게 뭐야? What does that mean? Thank you. Good response. But let me put it in this way. Anybody doing a DC inside? 뭐냐? DC 쓰레기들. Some of the DC board, there is a one web board. They try to brag about their computers. They run a small testing program. How fast your computer is? They give a score, 7.1, 7.2. 혹시 그런 거 본 적 있어요? DC 같은 경우 자기 컴퓨터 이번에 새로 바꿔서 내 컴퓨터 뭐 돌리면 이만큼 7초 만에 다 뭐 이렇게 점수 주는 게 있어요. CPU 점수 주고. 혹시 그런 거 본 사람 있어요? 많이들 하죠. 많이들 하지는 않고 뭐 이렇게 관심 있는 사람들은 좀 하죠. 똑같은 얘기입니다. They do a same set of testing on the different machines and maybe get a score. If I get a higher score, maybe it's faster. Sometimes they also do this for the graphic card. They bought a very expensive graphic card and they give some score, but I don't know what that score means. But usually it means that they try to give that graphic card to do a very high computation. Many addition, many multiplication of a matrix. And then see how long it takes. And you put that score onto the web page. And someone else buy a new graphic card. They got a better score than previous one. Comparison. It's also a way of doing a comparison. That sentence is for that, this inside. 아직도 하는지 모르겠다. This inside. 그 이제 유명하지 않지? 여러분들 사이에서는 별로 이렇게 유명한 웹사이트는 아니죠. 누가 있나 본데? 우리 때는 유명한 웹사이트였는데 소위 말하는 그 잉여들의 집합소 해놓고 우리 때는 되게 유명한 웹사이트인데 요즘은 잘 모르겠네. 한다고 나쁜 건 아니죠. 자기에 관심 있는 약간 매니아틱한 거니까. Benchmark. If you try to find those programs that testing your computer, they probably call it as a benchmark tools. Benchmark programs. That, if you think of that, is probably same sentence. Measuring efficiency, let's go to the efficiency part. Analysis of algorithm. Study of the efficiency of the algorithm. What do we do? I already explained this part in the last class. Sequential search. Search name among the list of n names. Start from the beginning, compare the name to the corresponding phone number. If you find the name, they have a phone number of that person, so they print it out. This is a program that you already seen it before in the chapter 2. Okay? When I was explaining this very simple algorithm, 뭐지? NNT, yeah. 모르겠다. If name ni, then print ti. This is a general idea, right? You have a while loop outside. Y is greater or equal to I from 1. Something like that. So I don't care about the pseudocode itself. I care about name matching. Name and 1, no. Name and 2, no. If there's the name that I'm looking for is at the last entry of a list, how many comparisons do I need to do this? N times, right? Because the name that I'm looking for is at the end of a list. But if there is a no name, there is no name. 뭐라 그러는 거야 내가? There is a Let's say I'm looking for name Young. What if there's no Young in the list? Then I still have to go through the n times, right? Until and then I can say that there's no Young in the list, right? Just did a comparison. In the worst case, you still need to do n comparison of a names. And what if it's a best case? What's the best case in this case? I'm still looking for a name Young. If Young is right here. One comparison, exit the loop, done. One comparison. One comparison versus n comparison. Let's assume that each comparison takes some CPU time. I'm going to call that one comparison case as a best case, and worst case is an n comparison. Average, they say n divided by 2. Average is being calculated by, you do asking multiple times with the different names. And then you do it multiple times and see what's an average of all those stuff. We'll go into that later. So best cases for this algorithm for matching, finding name is best case 1, worst case n. Makes sense, right? So they're going to keep using this letter n to describe the efficiency of your algorithm. I call that as order n algorithms. Order of a magnitude. N can become a infinity. 아니야, 왜 내 이상하게 그렸어? 아닌가? 이게 인피니티 사인이네. 인피니티. Where do you see this? 이거 어디서 많이 나와? 야. 주겠지, 그죠? Where n goes infinity, then you blah blah blah. Usually the answers are either 0 or 1. 그지? Right? This is typical case. Have you ever expect to see this again in the computer science courses? You will see this a lot later. You will see this a lot. And it's a good thing. It's a good thing. When you take such math courses in high school, you probably wonder, why do I need to know this? Ever. Right? Why do I need to know this? Hopefully throughout the course I can give you why you need to study this and how can you use this type of notations in some places. Okay. 아주 간단하잖아. Okay, let me just delete it for a while. 이게 왜 맨날 0 아니면 1일까? 답이 왜 맨날 그랬을까? 맨날 이러지? 그치? 맨날 이러지? 그죠? I'm gonna use an x in this case. x go to infinity. Y is my value that I'm looking for. Close to 0. 그때 맨날 0 아니면 1이지. 1이면 이렇게 하는 거고 1. 그죠? 그래프 그리는 것도 맨날 가르쳐주잖아. 그래서 0 아니면 1 모르면 찍죠. 그죠? 둘 중에 하나 아니면 걸리겠지. 이러고. Graph ways. This is not very related at this moment. But anyway. So imagine we're going to call that x as a n from this point on. Order of a magnitude. Anything that varies as a constant times n, whose graph follows basic shape of n. Sequential search, we're going to call that as order n algorithm in both worst case and average case. How does the graph look like on this part? What does this graph look like? If you don't know this, 진짜 seriously? You need to go back to the high school. Okay, let me just. Okay, right. This is also called linear, right? Linear. 비례. My n increase. This is the time it takes or comparison takes. Depends on what's my n. I can find out how long it takes. So, simple matching, graph matching, linear functions. Discuss it. Sequential search always be n. N 100, N 10,000 graph just keep growing in this way. Of course, the slope will be different based on the what value. 이렇게 그리려면 어떻게 해야 돼? Some constant. 그죠? 뭐야 이거? 국민학교 때 나오는 걸 하고 있는데. 그죠? 아, 초등학교 때 나오는 거 하고 있는데. 야, 이거 가지고 심각하면 안 돼요. 그죠? 이거 가지고 심각하면 안 돼요. C as a constant. That's why they usually term C constant. Some number constant. 2 of n. This is 2 of n graph. But it doesn't matter. It's a 2 of n, 3 of n, 4 of n. This is all belong to order n algorithm. We're going to call that as any algorithm that follow linear function like, we're going to call that as order n algorithm. Linear function, nice. You can calculate nicely. Okay. Now we briefly know what order n means here. Doesn't matter. Doesn't matter it's here, here, here. As long as it's a straight line going this way, order n algorithm. And this value C will determine how fast it grows, how slow it grows. That's the only difference. 그죠? 기울기가 저거에 따라 틀려지잖아, C 값에 따라서. But still, everything is linear. Just difference is how fast it goes. Okay. That's it. That's done. And depends on the C value. This is how much work they should done it, right? For same amount of n. Yeah, I can't believe I'm doing this now. N maybe 5. More work, less work. Is it? Less work. 미치겠네. 내가 이걸 설명하고 있을 줄이야. 카메라에 찍히기가 민망할 정도의 수준을 지금 그리고 있습니다. 그죠? 그래도 리미트 그릴 때보다는 훨씬 반응이 좋은데? Only one thing to remember in this case, order n. Now they give you a small example. Something called a selection sort. Selection sort. Sort means either could be ascending and descending order, but usually means I have a set of random sequence of numbers, but all I want is I like to sort them in increasing ways. 1, 2, 3, 4, 5. Okay, so they ask you to build an algorithm to sort a set of numbers. Can you do this in order n ways? Or before you even think about efficiency, what's your idea for sorting a number? 어떻게 하면 돼? 우리 비슷한 거 하지 않았나? 자꾸 너무 쉬운 거 하면 챕터 1, 2, 3 띄워버리고 다른 거 합니다. What should I do? Algorithmic way, pseudocode ways. not in your brain. Anything. 뭐야? 이게 뭐야? 뭐 이렇게 해도 되죠? I choose first one and try to compare. Maybe. And then if it's the ones that I'm seeing is smaller, then maybe I swap the place. One thing. If it's bigger, just leave it. Selection sort is like this. There are several versions of selection sort, but this is given list. They create another list. They create another list. 5, 6, 11, 1, 2, 3. You can find the minimum, right? There was the algorithm that we have seen it. Finding largest among the list. 했어, 안 했어? 했죠? It's the exact opposite. I do it once. 1 seems to be smallest. Write it. Second part, so it's 1 no longer there. Do it again. 2. But if you try to think back of the finding largest or finding smallest algorithm, how many comparisons would I need to do? Of course, n is keep changing, but still. In order to find this one, each single step takes n times. So, of course, n keep smaller, but still n times. So what does that mean then? In order to find a one number, I need to do this n times. But I need to do this for n times itself too. 그지? 이거를 n번 해야 되지? So how do you compute the number of comparisons in this case? 이게 뭐야? n times n. n times n. Square. How do you draw n square in this graph? See? I don't need to go to the next slide. It's pretty much obvious. But as soon as you're looking at this graph, which one is going to be faster? Or which one takes much more comparison? If you try to compare linear versus n square. 뭐가 일을 더 많이 해야 돼요? If n grows. Let me draw this again. 이거 완전 재능 수학 수준인데 왜 이렇게 딴 나라 얘기하는 것처럼 쳐다보지? 그죠? (10년의) 공부 끝에 이제 그걸 깨달으니 어떡합니까? And if you choose the same point, same n, much bigger, smaller. So what can I say with this conclusion? N square algorithms probably worse than linear algorithms. So also n square probably have this too. C. Depends on the C. It might go this way, might go this way. What about n cube? 어떻게 그려? 뭐 이렇게 되나? 이거 어떻게 그려? 뭐 한번 이렇게 되죠? 한 번씩 더 꺾어주죠, 그죠? But as you increase, that line is close to this side. Increase more and more and more. can you program compute the algorithm of n to the fourth power 4? Can you program compute the algorithm that running this much? It would be difficult. It would be difficult. It would be difficult. So if you have a set of algorithms that you can choose from, which algorithm would you choose to use? Linear, hopefully. What's better than linear? Constant. Any algorithm is running like this, it would be best, right? 그죠? It doesn't matter how large n gets, always stay the same. Is there a constant algorithm? Yes, there is. Yes, there is. I already explained a large set of slides in this case. Selection sort algorithm, sort in ascending order. You can design it or do it in sorting in descending order too. Subtask within the selection sort. Subtask. Task of finding largest number in a list. In this example, I did the finding smallest number in this set of list. Subtask. In the big selection sort algorithm, I need another algorithm to find the largest or smallest. That's what it means by subtask. When selection sort begins, largest is so far, volume must be compared to the all other numbers in the list. If there are n numbers in the list, n-1 comparison must be done. N-1 comparison. I don't compare to myself. You see? It doesn't matter. Later, I don't care about minus ones. So eventually, everything will be n squared because n times n. 어떻게 하겠어? 실제로는 이렇지 않겠지? 실제로는 n-1 plus n-2 plus n-3 plus 그죠? This is pseudocode for selection sort algorithm. Get values for n and list items, set the markers for unsorted section in the end of the list. When sorted section of the list is not empty, do step 4 to 6. Select the largest number in the list, sorted in the list. But in the textbook, they referring to a marker. Marker means location they're pointing to. Next number, they're looking into this. So it's a slightly different from your textbook. So if you try to find any selection algorithm, the descriptions are a little different from each other. But eventually, idea is quite similar doing this. This is an idea for if n is 10, n squared 100, and number of comparisons that need to do in linear fashion, 45. 100, 10,000 to 4950. 1,000 is what? One more amount. 100,000 more, less. So you can see the growth ratio of each function. Much larger, smaller, as you're dealing with large n's. So that's why I said n goes to infinity. Then n square algorithm will be worse. That is for comparison part. I thought your textbook, the part that explaining the selection sort part was a bit bad. So I just simply look it up the wiki. With the many different examples, they eventually line up for linear ways. Okay, linear ways. So, and then they explained it nicely for if you have order n squared time complexity. We're still discussing for time complexity how long it takes. Order n square time complexity made it inefficient for large list. And they explain briefly on what they will do and give you a simple example for they starting with 64, 25, 12, 22, 11. They swap. Same ways of doing. Same ways of doing. So if you're interested, you can take a look. They also give the source code like this. Simply copy and paste. Copy. Just do it in any program that you wish. I think this is written in C, maybe C, yeah, C. So translation of the pseudocode into this programming ways. Okay. Important thing in this chapter is now we know what it means to have order n square algorithms, order n algorithm. Now you know the notation. Later they cover a other type of notation, omega, small o. Those things will come up in next semester, but big O is the most important concept that you can find. 찾아봐요, 혹시나. 뭐 비슷한데, 수업 시간 얘기한 거랑 비슷한데. Selection sort algorithm does n exchange one for each position in the list. Put the correct value in that position spacing. What about space efficiency? What about the space that I take in order to have a final set of sorted numbers? Original list copies n memory locations. This is my original list. Have a n space. N space. Storage is needed for the algorithm they discuss in textbook. They need a marker position. This pointer, they also need to store somewhere the address values. And then keeping track of the largest alpha value and its location in the list. Okay, I need another spot to write down the largest number in this temporary location, largest list in this, and 12. I need to write this down somewhere. That's the storage space that they need in order to implement the selection sort algorithm represent in your textbook. On the other hand, this, I need probably what? I need probably another n. Because I just simply create a new list again. So I need maybe 2 n spaces. In terms of space taken, this algorithm probably takes more. The space complexity, they call it. Order n, time complexity, and space complexity is different part. 하나는 시간에 관련된 거고, 하나는 얼마만큼 메모리를 잡아먹느냐에 따른 거고. 알고리즘 구현하는 거에 따라서 요거 같은 경우에는 2 곱하기 n 정도의 메모리 스페이스가 있어야 되는데 책에서 나온 셀렉션 솔트는 거의 비슷한데 요거 조정할 장소랑 n개 조정할 장소랑 그 할 때 가장 큰 거를 조정할 장소 따로 이렇게 가지고 있어요. 이렇게 하면 뭐 한 n 플러스 2 정도만 있으면 되나? In theory. That depends on the algorithm. Hopefully it makes sense, and that's why this figure was there when they were comparing 3 and 5 temporarily. I think this one was a smallest, so got the 3 temporary. The smallest among 2, 3. Write it down. Don't worry too much about this example in the textbook. It's perfectly okay to understand this way as well. 이렇게 이해해도 돼요. 책에 있는 셀렉션 소트 알고리즘처럼 안 해도 상관없습니다. Anything that suits you the best will be okay. So in summary, order of magnitude of n square or big O of n square algorithm that does c times any constant times n square works for any constant c. Okay, my selection sort is n square algorithm, big O of n square. sequential search that I was doing from left to right takes n, order n algorithm. I just give you the way to compare two different algorithms in terms of time complexity. Takes longer, takes less time. Even though in this case they're not doing same thing. Simple examples like this. Does it make sense? Does it make sense? 질문, any questions at this point?
저기 아까 n이면 다음 실행했을 때는 아까 하실 때 1을 했으면 1을 지우고 시작하시잖아요.
네.
그럼 그때가 n-1번 실행돼야 맞는 거예요?
맞아요, 맞아요. 정확하게는 아까 적었듯이 이렇게.
근데 아까 셀렉션 솔트 설명하실 때 셀렉션 솔트 하실 때 n 제곱번 한다 그랬잖아요, 항상. 그러면 저거 안 맞는 거예요?
크게 정확하게는 비고라는 뜻이 worst case거든요. 제일 많이 했을 때 이거 이렇게 해야 뭐 예를 들어 이렇게 하고 n 곱하기 n-1 이렇게 해야 이거 풀면 뭐죠? 마이너스 미안. 정확하게 비고의 데피니션은 이 중에 제일 큰 거. 제일 딱 극명하게 그림을 그렸을 때 제일 극명하게 그 모든 그 성격 이 그래프에서 모든 캐릭터리스틱을 딱 도미네이트하다. n 스퀘어는 무조건 이거 아니야? 파라볼라 아니야? 그죠? 뒤에 뭐 n이 마이너스가 나오든 1차가 나오든 2차가 이 전체 그래프의 성격을 가져가잖아요. 그런 의미로 한 겁니다. 그 충분히 가질 수 있는 질문이에요. 왜냐하면 지금 여기서는 우리가 비고의 개념이 worst다, average다 이렇게 얘기를 안 하고 그냥 크게 order of magnitude라고 얘기를 했기 때문에 그거 조금 복잡해요. 다음 학기에 나오는 과목에서 조금 더 자세할 겁니다. 대충 무슨 뜻인지는 알죠? 네. Any other questions? 질문. 뭐, you guys have seen this from elementary school for 10, 15 years, so I don't think you have a problem with this stuff. So basically, the graph I'm drawing here is another way of representing it. If you try to draw two different type of order algorithms, time complexity graph, then you can have something like this. There is an interesting point in this graph. It's what? They can cross. Okay, before we take a look at the log graph, what does log graph look like? Let's say 어떻게 그려? 뭐 이렇게 되겠지? 그죠? Log is usually log base of 2. Will there be an algorithm of running a log n? If you're given a choice for linear algorithm, n-square algorithm, and log n algorithm, all doing the same thing, which one do you prefer? Maybe. Even though we don't know what it is, just looking at the graph, I like to always stay low. Apparently, I already give you the idea for log n algorithm last class. Order of magnitude, order of n square, part of the job of programming documentation. To make clear any assumptions and restrictions about input size of the program was designed to handle. So sometimes you see a program, they probably don't say the algorithm running inside this program have an n square algorithm complexity. They don't say it. But they usually say if you try to run more than 10,000 lines of input files, you can't do it. What's the maximum number of lines allowed in Excel? 엑셀의 최대 라인 개수 몇 개까지 되는지 혹시 알아요? 리미트? 아닐걸. Last time I checked, it wasn't limited. it wasn't infinite. 10만? 10만? Not so sure because I don't use Excel anymore. But last time I checked, it was 6만 5천 뭐. 몰라. 요즘 엑셀은 더 많아질 수 있어요. As soon as we move to a 64-bit operating systems might be larger. But previous versions are limited. Maybe that's another way of saying that their algorithm is order of n square, n third. 한번 해봐라 오늘 집에 가서. 컴퓨터 뻗을 때까지 한번 라인 한번 해보면 어느 순간 갑자기 엑셀에서 더 이상 할 수 없습니다 이렇게 메시지가 나올 거예요. 내가 옛날에 쓰는 엑셀은 그랬는데 요즘은 안 해봐서 잘 모르겠어. 그래도 리미트가 있을 겁니다. That is a type of programming documentation. They give you these messages of things to be careful of while you're running a certain programs. Comparison algorithm efficiency only makes sense if a choice of algorithm for the task is at hand. 실제로 해봐야 할 수 있다라는 뜻으로 그냥 넘어가면 됩니다. It's okay. Ta-da. So try with a different type of constant. Constancy in this case is what? 0.001, very small number for n square algorithm. 100 for n linear algorithm. Eventually, this one exceed, but the point will be slower. So if you have such limitations, maybe it's okay to use n square algorithm at some point. Okay. Under certain numbers, then it should be okay. So it doesn't always, it's not always the case that you prefer linear algorithm. In the limited cases, case by case, it's all different. Okay. Because of that constant values you have to deal with. So now we have a basic understanding of how to compare a different set of algorithms in terms of time complexity. We briefly looked at for space complexity in this example, 2n to n plus 2. So I probably focus more on time complexity part, or n square. So they actually start to give you this set of algorithms to compare, considering all aspects of time and space complexity. Something called data cleanup algorithms, shuffle left, copy over algorithm, and converging pointer algorithms. So if you take a look at your chapter 3, there are big tables explaining the shuffle left and copy over algorithms. They give you a long list and they write down the numbers and how to shuffle left, moving around those pointers within the list. And there is no winner. There is no winner of all these three algorithms, but just give you a simple representation of how to compare on each. Shuffle left, data cleanup. Data cleanup algorithm, first algorithm, shuffle left. I'm just gonna read here. So data clean, it means in their way of saying it, they like to remove any zeros in the given list. They give you this list of numbers and their algorithm wanted to remove the zeros from those lists. Maybe zero means garbage. That's why they say data cleanup. 데이터를 깨끗하게 하는 algorithm. Data cleanup algorithms. Scan lists from left to right. When zero is found, copy each remaining data items in the list one cell to the left. If you find zero, move everything to left by one. Value of some valuable name legits. Originally set the length of the list is reduced by 1 every time a zero is encountered. Already give you a very simple set of pseudocode to follow. So next class, I'm gonna explain a bit more on this algorithm, the other algorithm, and hopefully we can discuss more on the complexity efficiency part. Any questions today? 아직 가지 마. Don't go. So, okay. I will call the attendance now. 출석 부를게요.